Hello guys, welcome to one more video from GATE 2020 and this is question number 22 and the question says like this. A component subjected to a tensile stress in a mechanical device is monitored periodically for cracks by NDT. The NDT technique can only detect the cracks, both surface and internal, which are larger than 1 mm. Keeping a 10% margin of safety, the maximum allowed tensile stress on the component will be dash MPa. And we have been given KIC, which is the fracture toughness, which is 30 MPa root m, and assume that the crack geometry factor as unity. So basically KIC, which is nothing but the fracture toughness or the critical stress intensity factor in mode 1 cracking, can be written as alpha into sigma max times root pi AC. Okay, so here alpha is nothing but the geometry factor, sigma max is the maximum stress that is experienced by the material, AC is nothing but the maximum length or the critical length that we will be calling. So here initially, in this particular question they said that it can actually detect larger than 1 mm. Okay, so that means this basically the critical length would be 1 mm. Okay, so if I just note down all the values, this is 30, alpha is given as 1 into sigma max into root of pi into, because this is in meter, let us also convert the mm into meter. So 1 mm is 10 power minus 3 in meter. Okay, so if you simply solve this, you will be getting sigma max to be 535.23 MPa. Okay, so we got the maximum stress, but is this the question? No. Of course, they are asking to calculate the maximum tensile stress only, but what is the maximum allowed principal stress with this particular margin of safety? So here there is 10% margin of safety. So in the consideration of margin of safety, what is the allowable tensile stress, maximum tensile stress? So basically margin of safety is nothing but delta sigma by sigma max into 100, which is equal to my 10% which is given. So delta sigma is nothing but sigma maximum minus what is actually allowed by the machine. So sigma maximum minus sigma allowed by sigma max, okay, into 100 is equal to 10. So here it is pretty much simple, right? So I can write 1 minus sigma allowed by sigma maximum is equal to 1 by 10 or 0.1. Okay, I can write this, right? So now from this, if you do, you can easily get sigma allowed by sigma max will be equal to how much? If I just take this on the other side, this becomes 0.9. Therefore, in the final step, sigma max into 0.9 will be my sigma allowed, which is how much? So, or maybe I'll just write this way, sigma allowed is equal to sigma max into 0.9. So 0.9 into the value that we got theoretically. So the answer would be 481.41 or 71 MPa. Okay, this is the answer, and of course they are asking you to round off to the nearest integer, so the answer would be 482. Okay, so this is how you need to approach this. So what you are getting from the fracture toughness of a material, we have calculated what can be the maximum stress that the material can experience for a given particular critical crack length, and then we have calculated the maximum strength. But here the NDT, whatever the equipment that we have, is actually allowing not the complete sigma max that can be experienced by the material, but they took a margin of safety of 10%. Okay, usually for safety purposes, the theoretical values, from the mathematical values whatever we got, the manufacturers will actually tend to allow you by taking some margin of safety. That means if the margin of safety is 10% here. That means whatever is the maximum value that the machine can sustain, they actually tell you 10% lower. They only give you the 90% of the maximum or the theoretical value. That is what this is. See, this is nothing but the 90% of what we have calculated, right? So that is what is the concept of margin of safety telling you. I hope the concept is clear. Thank you for watching, guys.